Hello everybody, this is Scott from Octava Engineering, and today we are going to do a deep dive into SERIAL Fanuc Pulsecoders, specifically as it pertains to testing them in the analytics module. So right now I am in analytics, so encoder analytics. My feedback type is going to be serial. My motor manufacturer is going to be Fanuc. And then we have our type model option as found on the Fanuc Pulsecoder itself. Now, there are two main types of serial Fanuc encoders. There's 2-wire and there's 4-wire. And it's not always completely obvious as to which one you might happen to be working with at any given time. But it does make a difference because the pinout designations between the two are different. So in this case, this is our build sheet for our 2-wire Fanuc feedback cable. And you can see the pinout assignments here compared to the older 4-wire feedback cable, which has 2 more data transmission protocols on the motor side. So it does matter which one you're working with, and it does matter which cable you're using. But how do you know which one you're working with? So in addition to the Pulsecoder here, so we have the Alpha i1000i in this picture that I pulled up on the internet, but you also have the type code of the encoder. And this middle part of the type code here will tell you if a Fanuc Pulsecoder is 4-wire or 2-wire. So if this middle number is 2000, 2005, 2010, 2020, it is going to be a 4-wire Pulsecoder. But if that middle code is 2050, 2060, or 2070, that is going to be a 2-wire Pulsecoder. So the easy way to remember that is if that middle number in the type code of the Pulsecoder is higher than 2020, then it's going to be a 2-wire Fanuc Pulsecoder. So now that we know which ones we're working with, let's dive into how the Pulsecoders work on the analytics screen. So for this example, I am using a 4-wire Alpha I AR128 off of a 4-pole pair Fanuc motor, so an 8-pole motor. And once I have my drop-down set up here, I'm going to hit Start Collection. So this is an example of a purely serial encoder that only has data and data not channels to analyze, only the 2 channels. So there's no analog signals coming out of the encoder. Our diagnostics window is verifying that encoder power is being supplied and also encoder battery power is being supplied to check the health of the battery. So as with any feedback device that I'm doing in analytics, as soon as I see power being supplied, and in this case battery power, I change my diagnostics window from voltage to signal characteristics here in the footer so that I can view real-time information on the channel that I'm going to be analyzing. Our middle right window here, our encoder specific information, is telling me that the battery is okay. The count is okay. The full serial count is displayed down here. The thermal is okay, which will actually throw a fault in a little bit because this encoder is loose. And then I have an index fault, which I just need to clear by rotating the encoder shaft a couple rotations. There we go. So as the system is prompting me, just need a couple rotations to make sure that the encoder is ready to be tested. And once we do those rotations, the test is now in progress, and you can see my quick report and my amplitude dial is lit up, and now I also have that thermal fault kicked in. So the thermal fault is a critical fault for these encoders. And it will trip eventually as soon as the encoder reports it, if the encoder is not connected. So normally you want to do this quick enough if you have a loose encoder before that thermal fault trips. If the thermal fault trips while the encoder is installed, then obviously you would want to check the thermal device on the motor. So we only have the 2 serial channels to analyze. And with our recent software update, the analyzation process is now automated. So instead of me having to manually click these channels here, as soon as enough data is collected on one channel, it'll automatically move to the next channel. So all I have to do is rotate it. And as soon as enough data points are collected, it'll automatically move on to the next channel for me. I can pause the test if I want to check something on the serial code and the output in more detail. If I click on To Scope, it'll pause the test, and I can take more time viewing the individual characteristics of this channel, and also view it out on the oscilloscope in real time. And I can also select both channels if I wanted to compare the signals on my scope in real time. Now, I will also say, if you are using the cable mate and a different cable other than an Octava engineering cable, the battery supply voltage, your cable is probably not going to be wired for that, depending on the manufacturer. So you may have to separately supply the battery power. Otherwise, you'll get a battery fault here in the encoder specific information that will also qualify as a critical fault. So if you are using the cable mate as opposed to an Octava engineering cable and you need more information on how to supply that battery power voltage, reach out to us at support@octavaengineering.com and we'd be happy to walk you through that. Or click the hyperlink and click email support there. All right, so I reran the test, this time fast enough so that the thermal fault didn't trip. All right, so not too bad. 92% overall score compared to a brand new known good encoder. Overall encoder condition is excellent. Both my data and my data not channels at about 92% here. If we dig a little bit deeper, no critical faults or out-of-bound occurrences. You can see the voltage level for 91% is just a little bit lower than the perfect 3.5 volts. If we click on the data tab, we can see exactly what it was. All right, so 3.2 volts, very close, not too bad. So borderline between excellent and good in this case, but still perfectly usable. And then the same thing for the data not channel. Amplitude strength for both, just slightly low compared to a brand new solid 3.5 volts. But that's nothing to be concerned about at this stage. And no out of bound critical fault errors going on. So that's it with purely serial encoders. A lot of the times, with some exceptions, as we'll get into in other videos, they're pretty straightforward. You just have the 2 channels that need to be analyzed. And then there's no analog signals to worry about. It's just the serial data. So that's Fanuc. I would say that's Fanuc serial. I would say the biggest thing is knowing the difference between 2-wire and 4-wire, as we covered. But yeah, that's it. Thanks for watching.